Okay, in this video we will be going over the division of polynomials. Let's first start with how to divide by a monomial, which is a polynomial with exactly one term. So the procedure for dividing a polynomial by a monomial is based on the procedure for adding and subtracting fractions. Recall that when we add fractions with the same denominator, like 4 over 15 plus 7 over 15, this would just equal the numerators added up, so 4 plus 7, over the common denominator of 15. And this would equal 11 over 15. If we reverse the process and start with 11 over 15, which just means 11 divided by 15, we can write it as 11 over 15 equals 4 plus 7 over 15 equals 4 over 15 plus 7 over 15, where it is written as two separate fractions. Therefore, we can generalize this and say that the procedure to divide a polynomial by a monomial is to divide each term of the polynomial by the monomial and simplify. So a plus b over c is equal to a over c plus b over c, and with c not equal to 0. Let's go over this with an example. So let's divide the following. We have a polynomial divided by a monomial. So to divide a polynomial by a monomial, we will divide each term in the numerator by the monomial 5. So we have 40x squared over 5 minus 25x over 5 plus 10 over 5. And then we simplify each term. 40 and 5 reduce to 8, 25 and 5 reduce to 5, and 10 and 5 reduce to 2. Therefore, our quotient is 8x squared minus 5x plus 2. Also, notice that when we divided a trinomial by a monomial, our result is still a trinomial. This will always be true whenever we're dividing by a monomial. For the next example, again, we're dividing a polynomial by a monomial. Therefore, we divide each term in the numerator by 3x. So 9x cubed over 3x plus 30x squared over 3x minus 3x over 3x. 9 and 3 reduce to 3, and for the x's, we apply the quotient rule for exponents and subtract the exponents. Doing so, this simplifies to 3x squared. And for the next term, 30 and 3 reduce to 10, and we also apply the quotient rule to the x's, and this simplifies to 10x to the first power, or simply 10x. Then for the last term, the 3's reduce, and so do the x's. Therefore, this simplifies to minus 1. And our quotient is 3x squared plus 10x minus 1. Also note that x cannot be 0, because then the denominator would equal 0. Remember that a fraction is undefined when the denominator equals 0, and we'll talk more about this later when we get into domain. Let's try another example. We want to divide the following polynomial by a monomial. Although this example is written differently, it is the same as the previous example. Also, notice that the terms in the numerator are not written in descending powers. Let's rewrite them so that they are. Now we divide each term by 9m squared and simplify. We apply the quotient rule to the m's and subtract the exponents. Note that m to the 0 is just 1, so 2 times 1 is just 2. Then we need to fix the negative exponent and use our negative exponent rule. And now our quotient is 5m plus 2 plus 5 over 3m minus 4 over 9m squared. By the way, we could use a shortcut to the quotient rule. If we take this term, notice how there are more m's in the denominator, A shortcut for the exponents would be to take their absolute difference and then place the variable where there were more m's. So that will be in the denominator. So the absolute difference of 1 and 2 is positive 1. And there were more m's in the denominator, so that is where we will place it with an exponent of 1. This shortcut is useful to save us some steps. And again, notice how we started with 4 terms and we ended up with 4 terms. And again, our variable m cannot equal 0 because this would make the denominator equal 0. Now let's go over how to divide a polynomial by another polynomial other than a monomial. So when dividing a polynomial by a polynomial containing 2 or more terms, we use a process known as long division of polynomials. And this will be similar to long division of whole numbers, so let's go over the long division of whole numbers first as a review. Consider 4,593 divided by 8. We will use long division to divide this. We place our divisor on the outside and the dividend on the inside. So starting with 4, 8 can't divide into 4 evenly, so we can place a 0 here as a placeholder. Then 8 can divide into 45 evenly, at most 5 times, so we place the 5 here, and we multiply 5 times 8, which is 40. So that will go right under the 45. Then we subtract 45 minus 40, which is 5. Then the next step would be to bring down the next digit, 9, and we start the process again. 8 can divide 59 evenly, at most 7 times, so we place the 7 here. Then we multiply 7 times 8, which is 56. So that will go right under the 59. And then we subtract 59 minus 56, which is 3. Then we bring down the next digit, 3, and do the procedure again. 8 divides into 33 evenly, at most 4 times. So 4 times 8 is 32. We subtract 33 minus 32, which is 1. There are now no more numbers to bring down, therefore the remainder is 1. And then we can write the final result in the following way, where 574 is the quotient, 1 is the remainder, and 8 is the divisor. So now let's try applying this procedure to polynomials. Now we have a polynomial divided by a binomial. This tells us to use the long division of polynomials. We start with setting up our divisor on the outside and the dividend on the inside. We will work with the x in x plus 5, and we want to see how many times x can divide into 3x squared evenly. So what do we have to multiply x by to get 3x squared? That's just 3x, since x times 3x is 3x squared. So this time we will place that right here so that the terms in the quotient line up according to the degree in the dividend. Now the next step will be to multiply 3x with the entire divisor, x plus 5. So 3x times x is 3x squared, and we line this up under the corresponding degree. Then we multiply 3x times 5, which is 15x, and also line that up with the corresponding degree. Now the next step is to subtract this entire expression. So 3x squared minus 3x squared is just 0. And then 19x minus 15x is just 4x. And we can just remove the 0. If you wanted to, before subtracting, you could also distribute the negative first and remove the parentheses, and then subtract vertically. You can do whatever you're more comfortable with. Okay, so then the next step would be to bring down the next term. And then we start the process again. Remember, work with the x in x plus 5. Now, what do we multiply x by to get 4x? That will just be 4, since x times 4 is equal to 4x. So we line up the plus 4 right above the 20, since they have the same degree. Now we multiply 4 by the entire divisor x plus 5. So 4 times x is 4x, and then 4 times 5 is 20. And then we subtract this expression from 4x plus 20, distribute the negative, and then we subtract. 4x minus 4x is just 0, and 20 minus 20 is also 0. We have no more terms to bring down, therefore we have a remainder of 0. So our answer is just 3x plus 4. Let's try another example with a remainder this time. For this example, first notice that the polynomial in the numerator is not written in descending order of exponents. We must rewrite this so that they are. Now we can perform our long division and place a divisor on the outside and the dividend on the inside. So starting with the 2x, we ask ourselves, what do we multiply 2x by to get 16x cubed? That will just be 8x squared, since 2x times 8x squared is equal to 16x cubed. So we line up the 8x over the negative 38x squared, since they have the same degree. Now we multiply 8x squared by the entire divisor 2x minus 5. So 8x squared times 2x is 16x cubed, and 8x squared times negative 5 is negative 40x squared. And then we subtract. We can first distribute the negative. So 16x cubed minus 16x cubed is just 0, so we can cancel this out. And then negative 38x squared plus 40x squared is 2x squared. Now we just bring down the next term, 11x, and repeat the process. So we need to figure out, what do we multiply 2x by to get 2x squared? That's just x, since 2x times x equals 2x squared. So we place that above the negative 11x. Now we multiply x by the divisor, so x times 2x is 2x squared, and x times negative 5 is negative 5x. Subtract and distribute the negative, and we get negative 6x. Now we bring down the plus 19 and repeat the process. We need to multiply 2x by negative 3 in order to get negative 6x, so we place negative 3 above plus 19. Then negative 3 times 2x is negative 6x, and negative 3 times negative 5 is 15. Subtract and distribute the negative, and we get 4. And since there's no more terms to bring down, 4 is our remainder. Therefore, our final answer is our quotient 8x squared plus x minus 3 plus our remainder 4 over our divisor 2x minus 5. So as we saw in example 4, we must write out our polynomial so that the exponents are in descending order. We have to watch out for something else as well, and that's missing terms. So if a polynomial is missing one or more terms, we put them into the polynomial with coefficients of 0. So let's try an example of such a case. So the degree of this polynomial is 3, but it is missing the x squared term and the x term. We will insert them into the polynomial by giving them coefficients of 0. So we can rewrite x cubed plus 125 as x cubed plus 0x squared plus 0x plus 125. Now we can divide using long division. So we start with x and find what we need to multiply x by to get x cubed. And that's x squared. So we place this over the 0x squared term, and then we multiply x squared times x, which is x cubed, and x squared times 5, which is 5x squared. Subtract and distribute the negative, and we get negative 5x squared. Bring down the next term, 0x, and start the process again. We will need to multiply x by negative 5x in order to get negative 5x squared. So we place negative 5x over the 0x term, and then we multiply negative 5x times x, which is negative 5x squared, and then negative 5x times 5, which is negative 25x. Subtract and distribute the negative, and we get 25x. Bring down the plus 125 and repeat the process. We need to multiply x by 25 to get 25x, so we place plus 25 over the plus 125 term, and then we subtract, distribute the negative, and we get 0. There are no more terms to bring down, therefore our remainder is 0, and our final answer will be our quotient x squared minus 5x plus 25. For the next example, first we check to see if the exponents in our polynomial is in descending order, which they are, and we also aren't missing any terms for this one. However, for the second polynomial, this time we are missing the x term, so we rewrite our divisor as x squared plus 0x plus 2. Now we can perform our long division on this. We'll have to multiply x squared by x squared to get x to the 4th power. So we place x squared over the 5x squared term, and then we multiply x squared times x squared, which is x to the 4th. Then x squared times 0x is 0, but we can just write this as 0x to the 3rd as a placeholder. And then x squared times 2 is 2x squared. Now subtract, distribute the negative, and we get negative 6x cubed plus 3x squared. Bring down the next term, negative 8x, and repeat the process. We need to multiply x squared by negative 6x in order to get negative 6x cubed. So then we have negative 6x times x squared, which is negative 6x cubed, and then negative 6x times 0x, which we can write as 0x squared as a placeholder, and then negative 6x times 2, which is negative 12x. Subtract and distribute the negative, and we get 3x squared plus 4x. Bring down the last term, plus 11, and repeat the process one last time. So we need to multiply x squared by 3 to get 3x squared. So then we have 3 times x squared, which is 3x squared, 3 times 0x, which we can write as 0x as a placeholder, and then 3 times 2, which is 6. Subtract and distribute the negative, and then we get 4x plus 5. And since there are no more terms to bring down, we are done, and 4x plus 5 is our remainder. So our final answer is our quotient, x squared minus 6x plus 3, plus our remainder, 4x plus 5, over our divisor, x squared plus 0x plus 2, but now we can just rewrite this as x squared plus 2. And now the last thing to go over is how we can express this operation in function notation. So consider the following example. F over g of x is the same thing as f of x over g of x, which just means to divide the two functions. We can actually identify our domain for this. Normally, we'd be able to plug in any number in for x. However, since we have a fraction, we can never divide by 0. Therefore, our denominator cannot equal 0. And the value of x that will make the denominator 0 is negative 5. Therefore, our domain is all real numbers except x equals negative 5, or in interval notation as -infinity up to -5 union -5 up to infinity. And now let's perform our long division. And we get 3x plus 4 as our answer. So f over g of x is 3x plus 4. And now to find f over g of 2, we just plug in 2 for x and simplify, and we get 6 plus 4, which is 10. So f over g of 2 is equal to 10.